So today we're going to be talking some more about volume. Just a reminder, this is our math lesson on volume. We will have reading groups after this for Hufflepuff and Ravenclaw. Hufflepuff, hopefully you've already read James Fortin. And then we'll have math group this afternoon for those who normally spend time with me after school on Tuesdays. Tomorrow morning we have our Kahoot Science quiz on everything you've read for science so far. So please get your science reading done by tomorrow. And that means you should read either volcanoes or earthquakes. There's going to be questions on each, and I know that some people will only be able to answer one or the other. So for our math talk today, I want you to take a look at my new friend here. I haven't named my robot. I'm sure some of you have ideas. But how could you estimate the volume of your robot? In your chat, please put an estimate for the volume of our robot. And if you have something that you would like to share and explain how you got your estimate, you can put the asterisk or the little star after your answer. Thank you, Skylar. Thank you, Sergio. How many cubes do we think made our robot? And if you would like to share how you got your estimate, you'll put a star next to it. Love everyone's participation, seeing some really interesting estimates. I see that Violet has something to share. Let's give people another few moments, but meanwhile, I'm going to unmute people who have said they want to share how they got their estimate. And it looks like we only have one volunteer to share. If anyone else wants to, make sure you put a star with your estimate. Violet, tell us about your estimate and how you got to it.
I looked at each section. Oh, wait, let me just find my estimate within all of the answers. I thought it was about 57. I looked at each section and estimated how much was in each section.
So what would you call a section? Is a foot a section, or are you talking about like the colors?
Oh, I was thinking like the body, the legs, the arms, the wings, and the head.
Yeah. So what was the biggest chunk to estimate?
Like the torso.
Yeah, the torso.
I was thinking possibly about 30.
Okay. Awesome.
The arms, it looks like it's just about like 8 or no, sorry, the legs look like they're just about 8. And the arms look like they're just about 10. And then the wings look like they're around 10, 12, something like that.
Okay. Thank you, Violet. Martin, how did you get your estimate?
I just counted the cubes.
You counted the cubes? Yeah, and that can be a way too. Whatever works for you to get a fast guess for estimating. Excuse me. And I see Blue with some stars, so Blue will be our last share. Blue, how did you get your estimate?
I'm on.
Then why? Martin.
I'm on
Blue, is your mic maybe not working? Okay, you can type into the chat, Blue, how you got your estimate if your mic isn't working. But I hope maybe you have some ideas of how you would make a different robot. I did post on Parent Square last week where your parents can get these cubes online. Next week, for those of you who are trying to do some fun things during spring break, you'll have the opportunity to build your own robots and submit a picture of them, and you can use them with cubes, build them with cubes. You could go get some sugar cubes at the grocery store, or you could use cardboard boxes and make a really big robot. But we're going to continue to talk about volume today. So as we go to our next idea in this area, I want us to think remember what we did about a month or two ago. Who remembers the penny challenge? See if this video, you can say me in chat if you remember. You might remember this video from when we did that. And in this, a lot of you realize that if we just figured out the base and how wide the bottom was, and then went by how tall it was, we could figure out how many pennies could go into our cube. And so when we're getting into talking about volume, thank you. I'm so glad that so many people remember that box. It was a lot of fun, and we had Miss Beck's help with it too. So we had so many things. You had some really good ideas about how to come up with volume in that. So what we're doing with volume is not actually something that's that new for you. A lot of you already have these ideas. So I'm going to read this story, and then we're going to come up with some ideas about some questions we could ask, just like we would do any other free read in class. So I'm going to go ahead and unmute Maya, who I think has a working mic today. Maya, can you please read our story? Yep.
Okay. Should I?
Yep, can you read?
Louise has invented a new type of cereal box. Where every marshmallow in its grain is a perfect centimeter cube to fit the most cereal possible in the box. The regular sized box of cereal measures 2 in by 10 in at the base, and it is 13 in tall.
Thank you. And just as a reminder that in is an abbreviation for inches when you see that in a math problem. So what about the second part of our story? Violet, can you read it? I think you're still unmuted.
Yeah. He also decided to guarantee that there will be 1 marshmallow for every 4 grain cubes to ensure a marshmallow in every bite.
Thank you. So when we're thinking about this, what are some of the quantities and units in this story? Go ahead and use the chat to share what are some of the quantities and units in this story. Less with the highs and hellos in chat, please. It's not appropriate. The chat is for learning. So remember, you want to say your quantity and your unit in chat. So instead of just saying 13, for example, so 13 inches, Aya, thank you. Make sure you say your quantity and your unit. And I'm taking them from the chat to fill in here. Thank you for the clarifications. Let's see, and 10 inches. Are there any others? Did I miss any? If I missed yours, please retype it into the chat. Did I miss any other quantities? I think we have the 10, we have the 14. 1 cereal box. Thank you, Enzo. We always forget that one. 1 spoon is not in the problem, so we're not sure how many spoons are here. That might be a non-mathematical question we could ask. So thinking about these quantities and units, and let's remind us of the story. Louise has invented a new type of cereal, Boxos, where every marshmallow and grain is a perfect cube to fit the most cereal possible in the box. The regular sized box of cereal measures 2 inches by 10 inches at the base and is 13 inches tall. He has also decided to guarantee that there will be 1 marshmallow for every 4 grain cubes to ensure a marshmallow in every bite. So we should remember what we're going to do next. I want everyone to come up with a mathematical question that you could ask about this situation and share your ideas in the chat. The only thing that I should be seeing in the chat right now is possible mathematical questions. We have all our quantities and units. We don't need to list those anymore. What is a mathematical question you could ask? How much cereal is in the box? Fantastic, Martin. How many marshmallows per Violet? I don't even know how to say that number out loud without. What punctuation do you need to put on that to make it a readable number?
Commas.
Thank you.
I just spammed a bunch of number keys.
So let's make it a true mathematical question. Thank you for acknowledging your spam. How many marshmallows? Now, we couldn't figure out how much sugar without knowing the nutritional information, but I love how many people are asking about the sugar after we talked about that in our health lesson on breakfast a couple weeks ago. Okay, so I'm going to type a couple of these ideas that you have shared into some of our questions. Putting it over so I can see your questions too. How much cereal in the box? How big would the box be if it was half the size? How many marshmallows? Non-marshmallows. What is the area of the box? Now, are questions number 1 and questions number 5 going to be the same? Yes or no in the chat? Would question number 1 and question number 5 be the same question in this instance? Okay. I see a lot of no's. And let's see. Aya, mic check. Working, Aya?
Me?
Yep. Why are you saying no? Why is question number 1 and question number 5 not necessarily the same?
I didn't say no.
Oh, I thought you did. Okay, why the same? Oh, sorry, not Maya, Aya. So I don't think Aya's mic is working. Sorry, I know we're on. So let me see. Who else said? Oh, Sergio. Sergio, why would they not be the same? Why do you think number 1 and number 5 would be different?
Because it says in the fifth one that says what is the area of the box, and the other one says how much cereal is in the box.
Yeah. So, and those are totally different questions, but in this case, Luis has designed the cereal so that every pit of the inside of the box will be filled with cereal. So his goal is that there will be no difference between how much cereal and what the area of the box is, but we can't be positive until we test it out. So we would have to check that out to make sure that that was true. But without having the actual cereal in the box, it's going to be really hard to know for sure how much cereal is in the box. So we know how much cereal should be in the box when we figure out the area. But I'm going to take away that question because we can't be positive without seeing it. So we want to remember our mathematical questions. Thank you. So most of you are probably going to want to work on question number 4, but some of you are going to want to challenge yourself with numbers 1 or 2 or 3. So I want you to go ahead and work independently. Try and get your camera working too so that you can show your work. For some people who maybe want a little bit of help on how to get started for number 4, I want you to go ahead and watch the video that I'm posting into the chat that will show the problem with some linker cubes.
Okay.
If you know how to get started though, then go ahead and get started without the video. But if you need help getting started, go ahead and watch the video.
I'm watching the.
Thank God.
We're still recording, so you're all still muted. If you have questions, go ahead and type them in the chat. We're going to come back together and start to share in about 30 seconds. But we're going to go ahead and focus on start with number 4, and then I will invite people to share for the other questions. So I'm going to have you go ahead and watch.
So if we think of the base of our cereal box as 1 deep times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide, we have 20 cubes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this becomes our base. And that assures that we know that 2 times 10 equals 20. So now we have to stack 13 of these on top of each other. So we have 1, 2, 3, 4. I'm just going to flip this one over and push them all into each other. 5, 6, 7, 8, 9, 10, 11, 12, 13. And it's gotten higher than our camera, but we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if we count by 20s, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260. So we know that our ultimate, our 20 times 13 is 260, which means that if we had gone from the beginning, our original 2 times 10 times 13 equals 260. So the volume of the box of cereal would be 260 cubes.
All right. So that's how we would solve our problem number 4, is by using our manipulatives if we need to, but multiplying the 3 different dimensions by each other. So 2 times 10 is 20, times 13 is 260. So I'm going to unmute Polly to talk about question number 1, and then I didn't see anyone solve question number 2, but I'm expecting some of you to have challenged yourself by doing that. Thank you. There we go. So I will ask Calvin to explain number 2. So I'm going to, oh, you know what? I don't think Polly's mic is working anymore. So do I have a volunteer who knows their mic is working to talk about question number 1? So Emmett, thank you for sharing it via chat, but I'm going to ask you to go ahead and share with us your approach for number 1, and then Calvin will talk about number 2. Go ahead, Emmett.
Wait, which one?
Number 1.
Okay. So I multiplied 10 by 13 and I got 130. So then I multiplied that by 2 and then I got 260. And then I divided that and then I got 130 again. And then that was the answer because that's half of the box.
Awesome. Thank you. Calvin, how did you figure out how many marshmallows should be in the box?
Can you hear me?
Yep.
Okay.
Yeah.
So I knew that there were 260 pieces of cereal inside the box, including the marshmallows. So then it said that one in every 4 would be, 1 in every 4 grain cubes was a marshmallow. So that meant that I divided 260 by 4 and I got 65.
Thank you. Would anyone like to respond to Emmett or Calvin? I see a lot of people saying that they agree. I can unmute anyone if they want to build on. We do not have a build on symbol in chat, unfortunately. I wish we did. We need more emojis in this. But it looks like we have a lot of agreement. Okay, Caleb, I'm going to unmute you. Caleb, go ahead.
Can you hear me?
Yep.
Oh yeah, I thought the same as Calvin, like, cause 130 divided by 2 is 65.
Yeah, exactly. 130, so 130 was already the whole thing divided by 2. And then we divided by 2
again by 2, it's 65.
Yeah, so you ended up getting fourths of the 260 was 65. Thank you. And then Violet will be our last person to build on, and then I have one more extension to share with you before we conclude our math lesson. Violet?
I disagreed with Calvin because it said 4 every 4 grain cubes. So I thought it would be added on to the 4 grain cubes because it said 4 and not per or something. But anyways, so I divided it by 5, and I got 52.
Thank you. So that's where it is. It's tricky wording there. And thank you, Violet, for pointing that out. And I heard Calvin not being sure, and I was really proud of how he just picked one and committed to it as we went through. So when it is 1 marshmallow for every 4 grain cubes, when we write ratios, and ratios are no longer a big part of 5th grade math, but I will be probably giving you some opportunities to practice for some of you who want to do some problems of the week type things with ratios, and we've done a little bit. You write your ratio as 1 to 4, like that. 1 with a colon and then the 4. And that actually means that the total would be 5. And it's 1 in every 5. So if it had said that there would be 1 marshmallow out of every 4 cubes, then the ratio would actually be 1 to 3 and 1/4. So I really appreciate everyone who shared, and thank you, Violet, for pointing that out, because that was this was why we had this challenge today to talk about. So my last challenge for you is, if the supersized box is double the width, do we have enough information to know the volume of the new box? Put yes or no in the chat.
Yes.
In the chat. If it is double the width, do we have enough information to know the volume of the new box? Just because you're unmuted does not shout out. I see a lot of yeses, and I see some people who are not sure. So, Kobe, also known as Martin, I'm going to unmute you. Why is it a maybe? Maybe is a really good answer. Why is it maybe? Martin?
Huh?
Why maybe?
Maybe for what?
You said that it might be enough to know. What are we missing to know for sure?
We are probably missing, like, the height?
Yeah. Just because it says it's double the width, we don't know if the supersized box is taller. Think about when you've been at the grocery store aisle with your parents looking at cereal. A lot of times the supersized box is also taller, and we don't know that here. In our problem before, how big would the box be if it was half the size? We could infer that half meant for the whole thing. But here, we don't necessarily know the height. So I'm really proud of Martin for knowing that we might be missing some information. So that concludes our math lesson. If anyone has questions on any of the math assignments, we'll go into those in just a second. But before we talk about other math homework, I just want to talk about how everyone is staying organized. So in a second, I'm going to stop recording.